Okay, so welcome everyone to Compiler Architecture meeting. Today's topic, we only have one topic on the agenda. It is to talk about developing a specification for the Testarossa intermediate language. So this is, it's really sort of the lifeblood of the compiler technology. It's been in existence for probably 18, 19 years now, and without any sort of real specification behind it, other than what the Java technology sort of dictated it does. So whatever Java did, that's sort of what the spec actually was. But I think that now that there are technologies other than Java starting to consume OMR, it's probably time to actually start to formalize it a bit more and to put some rules around how the trees are structured, what the semantics of the various IL opcodes are, what the properties mean, and try to understand what the different components of the IL actually are, and with an end goal of actually documenting some of this so that people can understand it, and to actually do some validation of it as well, so that we know that when there are trees and other things like that are not compliant with what our understanding is and what the specification says. So what I did was I started sort of an epic issue here in the Eclipse OMR project 2569. If you want to sort of bring that up and follow along. I'm not going to bring it up on the screen right now because I want to take some notes as we go through this, but feel free to bring that up and follow it through. But in there, I threw down some basic ideas of the things that I think that we need to cover in developing this specification. What I was hoping to accomplish today was to really sort of introduce this idea and to collect input from everyone on really it's sort of a brainstorming session on whether or not you think this is a good idea. If you don't think it's a good idea, why don't you think it's a good idea? And what kinds of things do you think should make up the specification for the IL? And perhaps we can start talking through some of those things. I certainly expect that this is going to be a fairly large undertaking, and it's not one thing that's going to get it's not going to get done overnight. It's going to take some time. I mean, like I said, this has been technology that's been 18 years in development, but I think it's good to get a start on this and for us to kind of come to an agreement as to the direction that we want to go. Without further ado, I think that just following down the points that I have in that issue, I think that one of the first things that needs to happen is to provide some kind of a definition as to what the compiler technology thinks an IL actually is, what it's attempting to achieve, and to understand what the different components of that IL actually are. So without giving a huge amount of thought to it, the parts that I came up with were treetops, nodes, the actual IL opcodes themselves, symbols and symbol references for describing references to memory, and block, which is one that Mark wanted to add to this. So that was basically my understanding of, or my very quick understanding of that. Anything that anybody wants to bring up there?
Well, if you're going to put blocks in, I think you're going to need the CFG as well, right? The notion that you have a block, the control flow graph is sort of intimately connected with that, right? You can't really divorce the two, I don't think, in the current sense of how the IL operates, right? Like a block with no control flow graph or a control flow graph with no blocks, and neither of them really make sense.
Mm-hmm.
In principle, it would be possible to reconstruct the blocks from a series of instructions and the CFG from the blocks, but we can't do that because of exception.
Yeah. Mm-hmm. Yeah. But I think if we're talking about codifying things around blocks, then codifying things around the edges between blocks and the rules around how edges connect between blocks and different kinds of edges and where they leave and when they leave and how they leave. It seems intimately connected.
Like we don't have parallel edges.
Right.
For example.
Right.
So is a control flow graph required to be produced even if you're compiling it in NOAP?
Yeah.
Yes, I believe so.
Yeah. Like, it's not possible to have trees without the CFG in the current implementation.
At least one of our optimizations does run even at no-op simplifier, and it does require the CFG.
Right, so that's because many years ago, I don't think that was a requirement.
Okay, I cannot speak for whether the code gens require it as well.
Code gen requires simplifier because we assume
it requires simplifier, but But I guess is the reason that CFG is the reason that CFG is required simply because of simplifier.
You won't know the target of an exception throw. So if you are using the throw opcode to know what catch handler that will throw to or how it will leave the method requires that, because you won't have enough information to reconstruct that.
Yeah.
Or any exception point for that matter.
Yes.
Yeah. To emit the exception metadata, you need the CFG.
Yes. And to know the exception control flow, you need the CFG, because that's not expressed in the IL for the nodes that could potentially raise exceptions.
Or at least it's not in the tree. Arguably, the CFG constitutes part of the IL on that basis.
Yes. Right, but I guess what I'm saying is like a node, like a throw or a null check or a bound check or any other operation which could cause an exception to be raised, at least in the Java world, does not codify where the handler is or how to begin the unwinding process in the current frame.
Okay. Are there any other components of the IL that you think are worth specifying? Properties of the IL opcodes themselves? Yeah. Well, didn't call that out, but okay. Right. Okay.
If you're going to include nodes, does that include node flags or not?
Yeah. I was going to mention node flags.
I think it would have to be.
I think it would have to be, right? Like, they have a semantic meaning. They are supposed to be destructible, but not all of them currently are.
Well, even if they are all destructible, that doesn't mean that...
they shouldn't be codified.
Right.
Okay. So if we're talking about properties, I also had, like for symbols and symbol references, some of the flags and the attributes of those probably need to get defined as well.
Though I would say that there may be some places where some particular semantics may be dependent on how the code generators for a given language would interpret a particular flag. So one that comes to mind, just as an example for the purposes of framing the discussion, would be if you mark a symbol reference volatile, exactly what fences your language's memory model requires and how you flush and when you flush and that kind of thing may vary between implementations. Now, there's some implicit meaning about it, but there's going to be some wiggle room there. Similar kind of thing would be like a write barrier. Like when do you have to omit write barriers? What do write barriers report? Well, they capture the notion that you need to inform somebody about a particular store with some particular metadata. At the moment, they have a current set of semantic meanings in the context of OpenJ9's use of them from OMR. But conceptually, with a different garbage collector or a different language, they may serve a related but semantically slightly different purpose, right? You might, rather than just reporting references to the nursery added to the tenure, you may want to report other ways around or something else, right? Like there are pedantics around that may need to be left as language specific.
Yeah, the volatile one is a especially tricky one because it has potentially very different meanings on different languages as well as different architectures. So, yeah, you do need to decide what you want to do with that flag, what it means in an IL.
Yeah. Or whether there is a particular thing that naturally corresponds to volatile is also, like different languages might have a variety of, memory orders with which you can access, at this particular access and things like that, where a single concept of volatile doesn't map cleanly.
Okay. Any other components that anyone can think of?
I know Mark on the comments mentioned extended blocks when he was bringing up block, and I think the way that the blocks combine into extended blocks is important.
Yeah, there are especially constraints about how we extend blocks in Chapter as they're related to treetop ordering, which probably belong in the IL state. They are not intuitive from the academic definition of an extended basic block.
Mm-hmm. Yeah, we have a different definition. And it affects the commenting.
Yes. And uncommenting.
Sorry,
and uncommenting, right?
Oh yeah, well when we split blocks,
yeah,
etc.
Okay. Okay, so the next thing to provide some formalization around are the data types that these that the various opcodes deal with. So we have a number of them that are defined in OMR. So there's a variety of different scalar types. There are aggregate types and there are vector types. Anything to add to that?
Floating point type? I wouldn't have called those scalar myself.
I would have included those in scalar.
Yeah, but that was the intent.
You were probably thinking of including them.
Yes, that was the intent. So if we need different language for that, we'll describe it differently. Okay.
Sorry, we don't have a specific address for the data type called out here.
I had that in the first one as well, but I can call that out. The one thing that is not necessarily specified is really what the sizes of these different types actually are, right? Like what is the actual size of an integer? And is that something that we should do as part of this effort to really make it consistent across so that everybody knows, either we're calling it an int or, who knows, maybe we should actually call it a 32-bit or an I32 or something like that. I don't know. Throw that out there.
I think large amounts of the optimizer would already have that knowledge sort of baked into it.
Yeah.
Yeah, there's a sort of conventional terminology, but that conventional terminology strongly implies right now particular sizing of the integers.
So what we would have to do here, though, is to really put an actual number next to that, right? To say ints are 32 bits, and longs are 64 bits, and so on.
Yeah.
Right.
Yeah. I think the one area that may become slightly problematic are the address types.
Yeah, they have various interesting features, such as compression references.
Especially the notion of collected and non-collected references and reference compression. These things, because an address type represents many things at the moment, and the size of those things varies with time.
So, it depends on what you were taking the address of. So the question is, how do we actually handle that? Do we need to introduce another address type like a variable address type or a compressed address type or anything like that?
Well, the notion actually already kind of exists in the current implementation, in that we know if a given address is a collected or uncollected reference. The choice of when a compression or decompression operation takes place is more left to the code generators of the present time. There are constraints about when it has to happen, but there's freedom of maneuver about when a compressed representation needs to be decompressed, for example. So
is that a property in the symbol right now? Compressed
yes.
ref?
Yes, there are queries that take in the SIMREF and tell you if this field or this SIMREF is compressed or not.
Yeah, however, with the address conversion, so the fact that you can take an address and then convert it to an integer type and then back to an address, the notion of whether an address is a collected reference or not has to be computed across the tree. Like you have to look at the children to know, for an address typed opcode, you have to look at the address child of that address type opcode. So a memory indirect operation or an address relative operation, the collectedness of the address is based on the child, and that is not simply a function of the SIMREF at the bottom of that chain, but the conversion operations that appear underneath it. There was a huge piece of work done by LeCun on that to make that consistent so that we could decide it.
Okay. I believe compression is still answerable using SIMREFs, but collectedness is not.
Yes.
In terms of compression, one way of thinking about it is that we, like the value of a node can't get a compressed reference as the value. It can only get the decompressed reference, and that if the cogen wants to fiddle may.
Yeah, there's scope
in such a way that it is not observable, but yeah.
Mm-hmm. Yeah. In other words, it may transiently be a narrower value as long as that narrower value is never observed as a narrower value.
But that's quote unquote an optimization, or is more in that sort of scope. Yeah. For all intents and purposes, compression should not be visible to you as such as an user.
Yeah. The thing that is visible is the collectedness.
It is visible in array accesses, where it affects the stride.
Yes, that is true.
Right, but even there, when you read the value out, what you get is an uncompressed value.
Yeah.
Right, but you can't do the entire array access as though it were uncompressed because you'll access the wrong location.
Yeah, but I guess the stride there, though, is not implied by the A type of the operation. It is a function of
how the array data is stored.
How the array data is stored, which is part of the object model for a given language, right, which is really not part of the IL. That striding would be done during IL generation as part of knowing the semantics of the language that you're generating trees from.
Yeah, that sounds good to me.
Yeah, I think that resolves some of the conundrums around that.
Okay, so we also have the notion of an aggregate type. It's not really used in any great extent at the moment in OMR, but it's really there to represent the notion of perhaps a larger structure. Now, I'm not sure how much we actually want to define what an aggregate means as part of a specification, because that is something that we could go down that path if we wanted to actually provide more information about that and how they should be used.
I think it's more of a function of how much does the optimizer or other components within OMR examine that data type and or manipulate those data values, right? If for the most part they just sort of whistle through, mostly unaffected, then it can be left more loose. If the common optimizer is going to do things with it, then the semantics need to be more well-defined.
And then we've got vector types as well. So, okay, anything else on data types?
One question which is probably going to pop up is, what about unsigned, and how is that modeled?
So I think the way that things are currently handled. These, I think, are more representative of the sizes of the actual data types, and then the signed or unsignedness comes on the opcode, the operations themselves. That's fairly well baked into TRIL. There are examples, something like even what Mark was getting to in his, about some of the vector opcodes that are basically typeless, and signed unsignedness. The way that TRIL is evolved is really to put the signed or unsignedness on the actual opcode itself. Changing that, I think, is going to be a very large task. That's what anybody was thinking of. But
there have been evolutions where it has been where the signedness was included, and that caused non-trivial issues. So the current iteration has lessened the pain in that regard, and I think that changing it further is likely to cause serious issues. So I'm inclined to stick to the current notion.
Yeah, I also think that the deduplication of otherwise completely redundant operations is a very good thing. We don't need 2 adds and 2 subs and 2 consts and silly things like that. 2 muls. Although we do need 2 mul h's, but that's fine.
Okay.
Well, and it more closely reflects most processor ISAs, right? Most processors, the various operations that aren't really affected by sign do not have 2 versions.
So the places where we have signed and unsigned versions of opcodes more closely match where there are different instructions for those 2 operations. Platforms.
I think it's a principle of least surprise in my opinion.
There are lingering opcodes hanging around, though. There are those unsigned unsigned loads, unsigned calls.
Well, they would be dying.
They need to get rid of them.
They need to die, in my opinion.
Yeah, I think so too. But I'm just mentioning that they're still there.
Yes. Should anyone be wanting to find something interesting to do, getting rid of them would be a worthy undertaking.
I'll create a issue, or I'll create a task for someone to.
That's great.
A big enough task.
Yeah, but
Well, the usages of many of them have been reduced. It's not that they're all used. It's hanging around in various tables in some cases.
Yeah.
In other cases, they are still used. So there are some that are more trivial than others.
Okay.
Oh, constants. There's an issue around assignedness in the constants where when you set, you can set byte or short or whatever it is, right? And things will get, depending on whether you set using the unsigned with the signed API, it will get 0 or sign extended. If you then later read the constant value at wider than what it was set from, you can get one of 2 values, only one of which is what you're looking for. So I think that it's at least partly a code issue rather than a specification issue. But it's sort of like, should we be saying that you're only allowed to read it at the width at which it was set?
I can't think of a use case which requires being able to set it at a particular width and read it at a different width, but maybe you know of some example like that.
I don't know of one, but it's easy to do accidentally.
Yes, I would agree with that assessment.
Well, I'll give you an example. In the constant pool or in the literal pool, you can't store byte values, at least on Z cogent. I don't know how it is in other cogents. It has to be a multiple of 4 bytes. So if you want to store bytes, it would have to be stored as an N32.
Okay.
I just mean on the constant node.
Yeah, on the constant node itself.
Right, so when
Right,
you
but
say
you
I'm
need
going
to
to,
extract that value, right? Store it out.
That would be a detail internal to the code gen, right? The fact that,
right, the way that
Talking
you store
about
that
the
somewhere
field.
else is a different matter.
yeah, the field in the constant node
Okay.
itself, right? And you may have to deal with that other issue in the code generator, but the actual constant housed inside the constant node, right, would be, I think, the thing Devin's talking about.
Okay, I see.
Okay. Moving on, so once we've got sort of the components, we've got data types, I guess standardizing. Well, let me just reorder these two things here. So one other kind of component I guess you can think of here would be things like symbols and symbol references. We did take a shot at defining what some of these mean and how and when to actually use them. There actually is a document that was added to the Eclipse OMR code base that Leonardo wrote that takes at least an attempt at describing what these actually do. We may need to expand on that a little bit. We need to provide maybe a bit more guidance as to when to use one kind of symbol over another is appropriate, and what some of these things are actually for, and what kind of what kind of implications of using one over the other would have. And then, as we just talked about, defining on the semantics of various properties and attributes that these things actually have is important to do. Any thoughts, comments on that? Okay, so I guess the next thing is to actually start to define how the trees are actually structured and what rules are in place for what does a well-formed tree actually look like? What are the rules for putting together trees? Is there what can be in a treetop? What kind of side effects can they have? There's do you allow cycles? There's no. And the type consistency between parent and child and that sort of thing. So, any thoughts on rule formation or things that we're missing? We really need to be careful.
Pass-through nodes.
So guidelines like these, or rules, strong word, like these were discussed in a paper that we had written a few years back. That Matthew Godet, I think, was looking to incorporate into OMR documentation. So we have not done that. We should look into doing that because it has
I remember that. Yeah.
this set and more.
Yeah.
Okay, I think I have that. If I don't, I'll
I have it still.
track you down. Okay. Okay.
But yeah, the other one would be pass-through nodes. When they are allowed to be generated, when they're allowed to exist, there are a lot of parts of the optimizer that are surprised if they arrive at various places. They're expected to disappear relatively quickly. They exist for a purpose, but they don't. They are not a persistent part of the IL in the longer term as you do optimization, and there's parts of the optimizer that object rather violently to them.
At least
Do we want to consider that bugs in the optimizations, or do we want to say that we have weird restrictions on pass-through? Because that seems weird to me.
Yep.
Before we jump to the notion that we have to handle arbitrary pass-throughs, there may be implications in the complexity of the optimizer to be able to handle them in a large number of arbitrary places. So I think we need to be careful saying, well, we shouldn't have restrictions about them. I think that some care needs to be taken. We may need to define some sense of normalization or when they are allowed to exist, because dealing with arbitrary chains of pass-through nodes in the middle of all kinds of places can become extremely complex for some of the ops that are operating in the optimizer. So I think if the node exists It has a purpose. In the places where it's introduced, it's generally cleaned up at some point in relatively close proximity to that as part of a transformation. I think some study of those uses is probably warranted, and then some guidance on how they're supposed to be used is warranted. I'm not generally in favor of allowing arbitrary chains of meaningless nodes because it's going to make some of the things that we do much harder to do.
What I would say is that there's a difference between the complexity involved for not falling over when presented with something and the complexity involved for doing a good optimization job when presented with something. And the operation represented by a pass-through node is the simplest possible operation that we have. So it's a bit funny if we can't not crash, for example.
Okay, I agree with I agree that we shouldn't crash. However, I think some guidance for those uninitiated to the internals of this rather complex compiler on how they are used, when they are used, and the problems of leaving them in the IL for a long period of time is something that will be helpful to people that are new to this representation, because the node is there and the usage is not immediately apparent, I don't think, from where you see it introduced and how you see it introduced. It requires some subtle understanding of what's going on.
But there is to add to your point, there is a bit of a variability in how it gets used. There's contexts in which it just gets used as, here's something, just pass it on to the child, and there's nothing inherently being represented by the pass-through itself. And then there are other contexts where the pass-through does have some state associated with it.
Oh, right, it's used for GRA.
Yes, it's used under GL reg deps.
Yep.
The pass-through is actually used to hold on to the register number that the child wanted to.
Yeah.
So that may be something to either separate out into a different opcode or document in some way. It's not trivial. But,
Yeah, that makes sense.
Okay, the syntactic nodes like node check should be mentioned here somewhere. Not all nodes act on their child.
Yeah, and the broader notion of side effects that you mentioned here, there's a couple different ways of looking at that. One is, what is a side effect even? Like the act of throwing an exception is a side effect. The act of doing a store is a side effect. Doing a call is a side effect. Having rules around what is allowed, how many side effects are allowed in a tree is one thing. But then the other aspect of it, which because our trees are really DAGs, and you can have a node being referred to from two different parents, where the value of that memory location changes in between the two uses, right? That notion is always something that trips up people early on in the compiler, right? That this node evaluated under that parent could get a different value to evaluated under this parent. We really do need to make that clear. With a lot of confusion early on.
I guess the thing there to make explicit is the allowable evaluation orders. Because given trees, you're constrained to which one under which you have to evaluate any given node. Sort of, it's not ambiguous. It would just require codifying that.
Yeah.
That it gets evaluated here, and then later it's already been evaluated and you have the same value. That also affects where the side effects appear, because the calls can have returns value, and then they appear later, and they had better not get evaluated again.
Yeah.
Is the so I mean the evaluation order is typically driven, or the evaluation is really driven by the code generator. And I know that we've been tripped up many times in the past by code generators doing certain tricks to try to avoid generating a register or a store, that kind of thing in the code. wonder if we should put some rules around, perhaps what Devin was kind of getting, what was saying there was just put some rules around the actual order in which you're allowed to do evaluation and what is defined or undefined behavior if you do things out of order.
I think that's why we need to define what side effects are, because
Right.
those cannot be skipped. Whereas I can skip a multiply in the code, no problem. Can't skip a load.
Yep.
So things with symbol references.
Symbol references are different from that.
Yeah. Or, well, I guess it's also whatever the code gen that is indistinguishable from having done it in one of the allowable orders. Right? Like, it's not that you literally can't do such and such trick in the code gen. It's just if you do a trick in the code gen, it has to be as though you did one of the allowable orders.
And you can reassociate, for example, arithmetic like x plus y plus z. Maybe you could try fiddling around with the order in which you do that's an allowable trick. But reordering a load where there's a store that could change its value, not allowed.
So, I mean, other than, like we talked a little bit about pass-through, are there any other sort of very special kind of nodes that need extra consideration, like, for example, GL-reg depths, which have perhaps different semantics, they have slightly different meanings depending on the back end that's actually they're being consumed in.
I think we should document like senses and things like don't normally appear on, I guess, x86 and Z, but on power.
The various sense opcodes, the interesting behavior of the null check node.
And similar div check, resolve check.
The resolve check especially.
Resolve check is interesting from multiple angles. One, the child of the resolve check, while appearing to be a load, could actually result in a call happening at that point if you're loading a class. It could run a class initializer, which could run arbitrary code. But the resolve check can also be merged with a null check, for example.
Resolve and null check.
Those kinds of both at the same time combinations are relatively rare in the compiler.
Okay, so if we're talking about tree formation rules, and we also think that blocks and CFG should be part of this, I think that the rules around how and when you can extend blocks and what they look like, and how do you form, what does the CFG actually look like?
Yep.
Like the rules around how those are to be formed.
Well, yeah, and a discussion of the various, the two kinds of control flow edges, and the rules for those edges, when they are allowed, when they can arise, how they arise, when they are traversed. And a cautionary note about exception edge manipulation is probably warranted.
Or just anything in the presence of an exception point where you can exit the middle of a block.
Yeah. That is a rather unique feature of this IL.
Do we need to define anything or specify anything in regards to structure? Because I know that's pretty tightly coupled to the CFG.
I don't think so.
That's a thorny one. I would err on the side of not classifying structure as part of our IL because it is not created by the IL gens. It is not maintained by optimization. Oftentimes it's rebuilt. Sometimes it can be repaired and maintained, but many times it's rebuilt. It's not as essential, I would say, to the compiler as the CFG and the blocks. It's
not
more
having
optional.
not having the CFG means you do not have the exception semantic of what's supposed to happen. Not having structure means there's a bunch of optimizations that won't do anything, but
Well, if you had to, you could throw away the structure and rebuild it every time you want.
yeah. And even if you, for whatever reason, said structure, you will never build yourself. The optimizer can, for the most part, handle that. You might need to add a few extra ifs to bail out early, but in general, if structure building fails, life goes on.
We talk about trees again. Like whenever I say somebody new, I need to explain like basics. I always start with, there are three tops and they have side effects. I always list of trees and each tree has side effect. The children of a tree don't. It's very important. But then it was fine until I encountered compressed ref that has store under it. I find it very confusing. Like you can have store as a child. So maybe we should either fix it or put like a really weird expression.
It may or may not be fixable in certain cases. You can have a null check, for example, with a store under it. And while you could separate those two, it would largely be suboptimal. I mean, the null check is being done as part of the indirect store in those cases. So the rule generally is that you put the other indirect access under the null check. And in that case, the indirect access happens to be a store. Similar things are true for unresolved as well. Like you have a resolved check with an unresolved store under it.
That's true, yeah.
So I think it's not, I think your point is correct that the side effect is not always at the top of the tree, but I think it's still fairly well defined where it will be. It's either the top of the tree or its first child.
But I think those cases still should be listed sort of as an exception.
Because it's tricky, right?
Conceptually, tree is tree that has side effect, not its children.
You can anchor any tree to a treetop. That's not a side effect.
Yeah, that's just sort of pretending to have side effects.
Yeah.
If there is a side effect for this tree, it will be either at the top or at its first child. There could be treetops that have no side effects whatsoever.
Oh, yeah, they might not have side effects, yeah. But if there is side effect, and always, you're right, null check, result check, we do special, we always, when we go parse trees, we always treat it as a key. Because every optimization has to know, like, to check all children for side effects or not. So there's always, usually it does not only in those special cases. So maybe we should list that as a general rule with some exceptions.
Okay. Anything else around trees or blocks or CFG formations? No? Okay. And then I guess the opcodes themselves. I haven't checked lately how many opcodes we actually define in OMR. It's definitely well into the hundreds. But I think providing semantics of their operation that every platform can agree on, and what the expected output of executing that particular opcode is. So, for example, if there's some kind of if there's a divide, for example, what actually happens in the overflow case and that kind of thing. We need to be careful about documenting how they actually work. We've run into some issues recently with some of the floating points, with some floating point code where Java is expecting certain behavior to occur with not a numbers, but C does something different. So we need to kind of standardize what we want to do go forward with that.
I would say that we need to be a little careful about that because different languages will have different floating point rules. So if we are overly strict or overly specific in some ways about what OMR permits, expressing certain languages' floating point semantics may become very difficult.
In that regard, do you think floating point is morally in the same bucket as volatile, in that it truly depends on your language, what that actually means?
I don't know if I feel strong enough to be able to say that I feel that at the moment, but I guess what I'm saying is that some people, and I certainly have fallen into this bucket at various points, feel that have said, oh, well, the floating point operations, should be defined, to be, I don't know, IEEE 1754 or whatever, with whatever restrictions.
Mm-hmm.
But because OMR is a framework for many languages, and the notion of floating point semantics is a very language-specific choice. And in fact, some languages owe their popularity or their raison d'etre to how they handle particular kinds of numerical semantics, thinking particularly of some of the APL-based languages like R and things like that, where the particular mathematical properties of the representations are very, very important to that community. If we are overly strict in the definition in OMR, we may exclude certain potential users because they find it impossible to express the semantics that they require. So I think we need to, while I agree that we should consider what is worth standardizing, I think we should be a little careful about being overly specific in what we standardize on, because it may make it very hard.
Nothing stops you from overriding any of that at your language, though.
It doesn't stop you from overriding it, but it means that you would have to opt out of part of the common framework and some of the value proposition of OMR.
So the thing, like we're going through this exercise right now of adding floating point, more floating point optimizations to the optimizer, right? Like simplifier and value propagation. I guess in those particular circumstances, right, we want to be able to, we do want to be able to do some kinds of, let's say, folding operations on floating point values, but it also needs to be able to there needs to be some way of those optimizations perhaps to be asking, what do I do, like how do I fold A and B together, right, or how do I add these two together, and what happens if there's an overflow, and what happens if there's a nan or negative infinity, like what do I do, kind of thing.
Yeah.
So I think
I'm not saying that we should not consider this. I'm just saying that I think we should be careful to avoid excluding anybody on the principle that OMR should be accessible for anyone who needs.
I think there may be valuable lessons to be learned here by looking at what other multi-language compilers have done, right? Just to see how they represent floating point, how they represent volatile. There may be opportunity to learn from doing some research there.
It does seem like there are variable things like around these strange values that we get in IEEE, but then also things like, can I sort of, with air quotes here for those who can't see me, incorrectly assume associativity here? Can I, ignore those cases in this context? Can I use extra precision? Can I turn this into a fused multiply add, which is sort of extra precision, and all kinds of.
I think it will be a particularly thorny area that will require some significant consideration.
Yep.
Always struck me as a bit odd how when you have to fold to floating point, fold a floating point operation away because you know that it's on two constants, the compiler can't do it on its own. It has to ask the front end to do it on its behalf, right? Which in this world, tell me what this opcode means, right? In an OMR context, could be the position that someone takes. There's no asking anybody else. You tell me what it means. And if you had that degree of specificity, maybe the compiler could just do it on its own without asking anyone.
Well, we could certainly consider that design point. I think that this is the case of.
Yeah. Do we want to leave it loose enough that it is always the domain of the front end, or do we want to specify it so clearly that we can do it?
And it might be hard to look for interesting subtrees in that kind of formulation, because if the meaning is sort of arbitrarily determined by the front end, you have no idea what's interesting. You would have to sort of say, hey, front end, please optimize this tree for me, because you don't know what it means.
Which is what we do today, right, for floating point holding, for example.
Right.
Front end, please tell me what the value ought to be.
Well, I mean, there could be alternative design points that could be considered where we have OMR has a standard model that it uses, but we are clear that there are ways to opt out of that standard model if you want different semantics. If your code gen will do different semantics and you don't want OMR to mess with those things, then you can tell us a subset of things that you don't want us to mess with.
Oh, and there are rounding modes.
Yes.
Oh boy.
The joys.
Yeah. Okay, so in the issue here, I just very quickly sort of categorized a variety of different opcodes into various different categories. That's by no means a complete list, and probably a lot of stuff still falls into the miscellaneous category. But anyways, when it comes time to documenting, I think it would be interesting to line opcodes up under those kinds of categories. I think, like Philip already brought up the notion of properties. I think that the various properties on each of the IL opcodes, we need to come up with a clear definition of what it actually means.
I think for opcodes, more than for any other aspect of the IL that you discussed, there have been attempts in the past to do documentation. We went and looked at the code base. I think they're actually in the code, not separate documents. They're in the IL opcodes HPP file or one of those files. So you may have a look at what has been documented, the format that documentation is in, to see if you want to use the same format or not. You don't want to have like multiple different kinds of formats being used in the documentation.
I don't think we should. I think the documentation should be coupled with the drill test. Otherwise, it's kind of meaningless because it changes over time.
Mm-hmm. Yeah, I mean, I think validation of whatever we come up with here, I think, is going to be particularly important, and making sure that it stays. So I think that developing drill tests to really exercise a lot of this, I think, is important. So.
And extending the IL data.
Yeah.
Yep.
Okay. Anything else on opcodes or opcode properties?
I have something I'd like to add.
Oh, hey, Leonardo. Sure.
Hey, everyone. So, just from experience, being clear about the expectations with the, the array copy opcode with the 3-child and 5-child variant.
Well, I think that
arguably, I think that particular one, we should just bite the bullet and create 2 different options.
We did.
Okay.
Deprecated.
I am completely in favor of that solution. I still think it should be documented somewhere until that happens, that this is a thing, if only to warn people that be careful when trying to use the top code.
I think we did deprecate those. We have a reference array copy and primitive array copy now.
I don't
that's been done okay.
I don't know they've made it everywhere yet, so I've still seen array copies coming out of various places. So.
Okay, I think you might be right. We've made the change at the VP level where the 5-child is actually created. We didn't separate the IL yet.
Yeah. So,
and that's the missing piece.
Well, and there are other places, I think, in OpenJ9 that would care about it.
Yeah.
There are going to be opcodes that are found that have a many varied and sorted history around how they've been used and are not beautiful things that we wish to codify, and we may just there may need to be this is deprecated, and we're going to define the new set of opcodes that represents that thing, and we just sort of call out that such and such is not specified, it's currently being used by OpenJ9 or whatever. Don't use it, it will go away. Here be dragons, kind of thing. Because we are going to find them. I mean, 15, 20 years worth of evolution. I mean, it's almost inevitable you're going to end up in some dark corners.
Yeah, although Leonardo's point is a good one, I guess, in that after the cleanup, that problem ceases to exist in the code base, but someone may be on a version of the code base that still has a 5-child and a 3-child array copy, in which case they would appreciate the documentation around that.
I certainly think that, when we make one of those transformations, we can say what it is that we're doing, but I think that the top-level specification and the documentation should just call out that this is one you shouldn't use, it's deprecated. If you have used it in the past, you can find out the gory details here, but that is only for the purposes of moving away.
Do we want to have some kind of guidelines around our exceptions to the rule and avoiding adding new exceptions to the rule, new things that act like null check and div check, new flags on nodes that you can't clear or that significantly affect the semantics of, it's going to compute a different function now, or nodes with different numbers of children, or
I think it's hard
for the different.
Go ahead, Leonardo.
I was just going to say, for the issue of different number of children, I would very much like that to go away because it makes validating trees much more difficult. It kind of causes a number of cases that have to be handled to grow rather unpleasantly, and it just really creates a mess. For things like the div check and null check, I'm not, off the top of my head, I don't really see a problem with introducing ones that have similar behavior, but I would like to see very clear reasons why we would want that. So, my 2 cents.
Those things have to be special cased in a lot of places. They're a huge pain.
I think calling out the pain and then.
I think it's going to be difficult. It's going to be difficult to put sort of guidelines around the kinds of exceptions that we want to make to the rule, but I think we're going to have to kind of deal with it case by case, and I think discussing it in a forum like this and then documenting the reasoning behind it.
Although in the paper that I mentioned earlier, we did get into philosophically kind of why you would want, and number of children was one of the areas that we discussed as well.
Okay.
I think we're stuck with that one, at least for calls, but there are, at least we want to say, let's please be trying to avoid doing this. And then you can look at things on a case-by-case basis. If people don't know to try to avoid doing that, then it sort of becomes like, did somebody who was thinking about this look at it at the time?
I think we could certainly have a set of principles.
Yeah.
Rather than necessarily guidelines or rules, but principles of operation, shall we say.
A whole book named that.
Okay.
I'm not going to comment on the ISA at this point.
So now that everyone's very lighthearted, let's talk about aliasing.
Oh, that ship for the kibosh.
Meeting adjourned.
There was one thing I wanted to mention before we moved on that I don't think I heard mentioned.
Sure, go ahead.
So I was thinking that we should decide whether we want the IL to be extensible by third parties, whether that makes sense or not, because what we have now is some of the opcodes are in J9 and some of them are in OMR, and as it stands, we have a lot of code in OMR that's if-def to J9 because it's very hard to deal with opcodes that are defined elsewhere. So do you want that to remain? Do we want people to have that ability? What are the constraints around that? Because it's going to color just about everything else that we do with the IL, whether or not somebody can come in and add things and things like that.
I'm of the opinion that, although this is not the case today, optimization should be acting on IL properties, not the IL itself.
While that may be while that is a valid position, I think that the fact that you are going to have common optimizations makes it very difficult to introduce IL opcodes with radically different semantics, because if an optimization is going to inspect the intermediate representation and try to make even conservatively correct assumptions about what to do, if you have a node or an opcode that has a behavior that is a radical departure from the current way that opcodes are structured and how things operate, it will be very difficult to ensure that every optimization will be conservatively correct according to whatever it is that you define. It's going to be very hard to define optimizations that will work in general if the currency on which it must work varies significantly. It's going to be very difficult to do that.
I think that goes to some of those principles.
Yeah.
Where basically, like, here's what we expect of an opcode that's not going to be surprising, where an optimization can safely ignore it and do something that's not to be blatantly incorrect.
I think if for extensibility to work, though, there would need to certainly be some, the current state of the code base is not one where you would necessarily get the behavior that you would want for. So I think that's something that needs to be considered.
So if we didn't allow extension, that would mean that any sort of operations, and I guess you can look at OpenJ9 as an example, any sort of operations that let's say OpenJ9 is doing right now would have to either be expressed in the current set of opcodes that we have in OMR, or would be allowed to introduce those opcodes, perhaps being very language specific or VM specific, into the set of IL that we have. So I'm not sure if you can, like, if you did, for example, if you wanted to introduce some kind of a special check node, if you could actually decompose that into IL opcodes that are already in the set of what OMR has, and whether or not you would be able to do the same kinds of optimizations based on that, right? Because you'd have to do, let's say, tree matching or pattern matching to find that, yep, this collection of trees is actually doing that operation that I'm expecting, and then you do your optimization based on that. I think that might start to get somewhat difficult to do unless you delegated that down to your project and let it do something like that.
Right, but I think that arbitrary extension is not something that is going to be easily done either. I think that there probably will need to be a middle ground somewhere between no extension and go nuts, where we need to be very careful how at the OMR level we advocate for people to do the extension and what kinds of extensions are expected or not expected and how they should look. Mm-hmm. Because if you wanted to introduce some node that has some very radical properties, like it, you know, you were going to operate on your second grandchild and,
nobody knows that.
Nobody knows, and it's not a thing that exists at the OMR level. Mm-hmm. There will be a myriad, the optimizer at the OMR level will either A, do the wrong thing, or B, not be able to do anything.
I would suggest this is a significant enough topic to have a separate discussion on its own, because there are at least two very different cases that a user may be looking at to extend, right? One is creating a new opcode. I just wanted to sail through the OMR optimizer without crashing and come out the other end. I don't care about optimization. I just wanted to get through. The other extreme is I'm introducing this opcode and magically lots of simplifications or hoisting and all those traditional things, I want those things to happen. So which camp are you in? What is the specifics of your opcode? How abnormal, quote unquote, is it? Are all difficult to reason about in generalities. I think you do need to break it down a bit more and discuss each issue.
But again, I think side effects
side effects
to optimize, right?
Yeah. Well,
it does not have
not just side effects. There's a lot
of, like the sensitivity to the syntax of the children.
But that's.
So I think that there's I think there's value in extension, but I think, as EJ said, I think it's a separate discussion on its own and requires a separate considered, once we have a notion of what our IL semantics are and what the rules are. I think we will be in a better position to discuss how extensions could fit into that framework, right?
Maybe certain kinds of extensions are more
amenable
or practical even in the code base that we have.
Yeah.
Certain others are worth pointing out as if you're going to do this, remember that these are the pitfalls.
Yeah, or you need to opt out of these optimizations or whatever.
That's a good point to bring up, Eunice. Thanks. Do you have anything more you wanted to add to that? Okay. Aliasing. I think that...
Are we still on the call? Maybe worth checking.
Can you guys still hear us?
I can still hear you.
Oh, okay. Thank you. There's some funny beeps going on here. We can't figure out what's happened. Okay, so aliasing. Defining. I think there is there is a role for at least defining the aliasing in the since we're talking about symbols and symbol references. I think there is a role for aliasing as part of the specification here. This technology, I think, does have a different set of terminology in some cases that it uses when talking about aliasing, and perhaps a slightly different set of rules in some contexts as well. I know that there are those that are wanting to use this technology that are interested in learning more about aliasing, and it's somewhat unspecified at this point how it all works without actually diving very deep into the code. So I think that it's important that we bring out what our aliasing rules are, and our terminology as well. I'm not sure if others have thoughts on that.
I think it definitely there needs to be documentation for how a lot of that aliasing machinery works, as well as what our notion of aliasing is. I don't know if it makes sense to standardize it as much. What would make more sense to me would be to standardize the interface for dealing with aliasing. And accompanied with that, you would need documentation explaining what aliasing is, but I would not consider that a specification.
Yeah, I would probably agree in spirit with what Leonardo just said as well. Aliasing is another one of these things that varies significantly, language to language. To draw parallels with other things that we discussed in this meeting, it's not built by the ILGen. It is invalidated regularly and rebuilt. It's mostly used to do optimizations. I don't believe, I could be wrong, I don't believe you need aliasing to generate code. You could just go ahead and generate code from the trees that you have, and that would still be correct. You don't need the notion of aliasing unless you're doing an optimization. But that then takes it very much into the kind of domain that structure was, right? Like an optimization that having structure permits. Optimizations are permitted by having aliasing. So is it an essential part of the IL? I'm not sure. But the interfaces that are there, what the queries mean, maybe are possible to standardize on without getting into the specifics of the language as such. And whether that needs to be made part of the IL or not is a different question, but it does need to be documented in some way, perhaps under its own banner. Yes, I'm long-windedly, I'm saying that I'm not sure if it belongs under the IL banner, but it definitely deserves documentation and treatment along the lines as Leonardo was.
Any other opinions? No? Okay. Okay, we've got about 15 minutes left and a few topics potentially to cover here. So I mentioned IL versioning. So this is the sort of notion that we do keep some kind of a version numbering system with the IL so that it's potentially comparable, like this particular opcode was introduced in version 2.8.4, that kind of thing. It could potentially go in lockstep with the OMR releases that are going to be coming in. Perhaps that's the way to actually do it, is to actually have it versioned with respect to that, as opposed to having its own independent versioning. So that's something to consider here as well.
I don't know that it would need its own versioning unless we were going to submit it somehow. Like if we had some format for serializing or a syntax or something wherein, right, like that might be something where you would necessitate a version, but otherwise, I mean, I guess the IL as of this version of OMR is about as specific as it could possibly need to be.
I guess Trill would have to be kept, like the version of Trill would have to, like the closest thing we have to serializing IL at this point is Trill. So I guess there'd have to be some kind of a connection there. But and whether or not, but even then you could still go with the release of OMR. Like if we're doing monthly releases, which is what the expectation is, it's going to be fairly regular. So
I think even with something like Trill, if we consider Trill to be part of the OMR project, presumably Trill will be updated at the same time as the IL is updated, so there would never be a case where they get out of sync, assuming we do things correctly, in which case, even then, there's not really a need for the two to have different version numbers. And I think as a whole project, it would help consolidate the different components of OMR if they all share the same version numbers.
Yep. Yeah, I'll agree with that. I mean, that's just wanted to throw it out there to see if there's any other opinions on that. So. Okay.
And I think it would be nice to be able to store or transmit this stuff some way, but that's a whole separate thing.
Yeah. Okay. Okay, and then I guess the last point that I just wanted to raise on this first call was around, I guess we've kind of touched on it already, it was around, I guess, testing and validation, and sort of the need for having some mechanism for ensuring that whatever specification we end up coming up with is met by the code that's being, or by the IL that's being produced. So, this is, getting into creating test cases with Trill, perhaps. We've started work. We started work on improving the IL validation scheme that we've had for a while, and perhaps that needs to be extended as well to handle more complicated rules that we have in our IL formation. Extend it to CFGs, extend it to blocks, that sort of thing as well. So I think that is an important part of any sort of specification that we end up coming up with. Opinions on that, one way or the other? Okay.
I mean, definitely, of course, testing and validation will have to be part of this to make sure that we are true to what we say and that our implementation actually matches what we document and specify. I do think there will need to be significant work done in the validation aspect, especially for being able to introspect the IL at different points during compilation to accommodate for the fact that through the optimizer, trees are going to change. And so maybe by the time the trees get to the code generator, the piece that we wanted to test is no longer part of the trees because it's been optimized away. So having mechanisms for dealing with that, even if they're only documented techniques for how to deal with that, is going to be very important, I think.
Right. I think it would be good to be able to generate some IL and just run an optimization pass. Just run this optimization pass, and then I want to, inspect certain properties of the output code, and probably I want to run it. Maybe I go to CodeGen. Part of the thing there is that it's going to depend on what CodeGen does, which is sometimes quite fancy itself. So it might make sense to have something like, can we just go and interpret this IL using the simplest possible strategy, just for the purpose of seeing what it says to do rather than right. And then you could have like the interpreter could be, something that clearly matches spec, and then you could say, take some IL, you know what it's supposed to do, and you can see that we know that it's supposed to do that, and then you can run it through CodeGen and see that it still does that. Or that's where you could sort of detect mismatches that way.
So trill interpreter.
And what are the cases in which a trill interpreter will be needed as opposed to just saying, here's the answer I expect you to get when you do this operation. I'm giving you a constant. This is the answer. If you get the answer, you're good. If you don't get it, you're not. Right? That doesn't require an interpreter in the traditional sense. It just involves a person writing the test to understand
I just meant
the specification and interpret it themselves, human interpretation of it, and come up with the answer.
Yeah, I guess I just meant that that's a separate, it's a possible way of separating concerns in the test. So that could be like a code manifestation of, right, so you could test optimizations without involving CodeGen. I'm just going to test just this optimization, right? Or similarly, you could test CodeGen without involving any optimizations. You could say, here's some IL. It goes into CodeGen. I need to get the same results that I get from over here.
I actually really do like.
Sorry, go on.
I do like the idea of an interpreter, only because ideally I understand how you would be able to just, the test writer would be able to just specify what they expect on the other end. But I think that what you would find is very quickly that would become difficult to determine, especially with some of the more advanced optimizations. Kind of being able to predict what the optimizations are going to do and what the trees are going to look like when they come out could become very difficult to predict. And it could also become brittle in that an optimization could change the trees it generates in a completely equivalent way, but just different enough that a test case would all of a sudden break if it's expecting a specific pattern of trees. So I guess really the problem to be solved there is how do you specify what it is that you expect? And having some sort of interpreter-like mechanism would allow us more flexibility than just specifying a specific pattern of trees. Okay, so
you're talking about cases when the output could be a pattern in the IL and not getting mired in specifying that pattern to check for as the output from the test, because if the pattern changes slightly, then test case gets broken. Instead, if you had an interpreter which was able to tolerate mild variations that ultimately boil down to the same answer semantically, that's preferable for that reason, that it would be able to accommodate those mild variations. Is that a fair summary, Leonardo?
Yeah, that's a good summary.
I think it does depend on what you're trying to test, though, right? If you're trying to test, I think that kind of thing is good for testing just that you didn't break the code. But you may want to test more specifically that you didn't optimization.
Yeah.
Right. We transformed this into.
Is what you're trying to catch. Yes. Right. Or well, somebody makes a change where an optimization suddenly doesn't do what it's supposed to, but the code still produces the correct result.
Yeah.
So you missed an opportunity where.
But how often does it happen?
All the time.
Mm-hmm.
I mean, pretty much all of our performance regressions are, we made a code change and some random thing down the line broke because trees no longer look in the way they're supposed to, yada, yada.
Yeah.
Okay. So I think that's is a good discussion to have. I think it's maybe getting a little bit beyond specification. So that was sort of the last point that I wanted to raise. So in the last 5 minutes, are there any other thoughts that anybody wanted to share or bring up related to IL specification?
I had a stray other thought about signedness, which is that we have the cannot overflow flag, which really means cannot signed overflow, at least in every place where I've ever seen it. So we may want to have a cannot unsigned overflow, or we might want to rename it or something.
I have a slightly tangential question, but we did touch on this topic in this discussion. Had a prior OMR discussion on this alias thing, node flags. Does that work come along since then, or is it on the backlog?
On the backlog.
Okay, so I think this is a good start. I think what the next steps here are to start to break this down into smaller tasks and start to make a bit of progress on defining some of these things. I certainly will have a look at the paper that Vijay mentioned and see how we can incorporate parts of that as appropriate into any sort of documentation that we have. This is going to be sort of an ongoing effort over the next while, but I think it's important that we get it started and get it out there for people to start consuming. So
there's also at least a couple of follow-on discussion topics that were mentioned.
There are,
here,
yes.
Including the last one about testing.
Yep,
seems interesting.
Much bigger discussion that we're going to need to have. So for sure. So happy to set up something as well where we can carry that forward. So, okay. Last call for comments before we adjourn. Okay. Thanks everyone for attending, and we'll talk. Bye.